So our human body, if you take, it's a very good conductor, because our human body is made up of that is most percentage is made up of water. So the resistance of the human body is around 200 ohms. It's around 200 ohms, and if it is a dry skin, means it is around 500 kilo ohms. The resistance is around, say, 500 kilo ohms. But if it is wet skin, means this resistance reduced to, say, 1000 ohms. So it is very dangerous to touch the wire which has electricity with the wet hands. That's why people, they wear what? Gloves. So that it is an insulator. So we use what? Gloves and all. Okay. That's all regarding that resistance. So we need, we have resistance. We studied about resistance. If in a circuit we need resistor to connect it so as to reduce the current in a circuit. So for that we use resistors like say coil wound on any conductors like this. It's what is called as a rheostat. This is a big one, heavier one. Or we can use small resistors like this. Actually it is these are called as carbon resistors. Actually it is made up of a ceramic core, and it has a crystalline carbon inside it. So we use resistors. This we prefer most because in an electrical circuit we use this resistors while we take output. That resistors which we connect across where we are taking the output is called a load resistor. So we always use the resistor to limit the current in a circuit. That resistors are called as current limiting resistors also. So these ceramic core carbon crystalline resistors are very cheap. It is inexpensive, so we prefer this. And even these resistors, they have different resistance values, say 100 kilo ohms, 47 kilo ohms, 1000 ohms, etc. But depending upon the need of the user, we can they purchase the resistors. But the manufacturers, they won't manufacture the exact value of the resistance. So suppose if we need 3000 ohms, suppose if the availability of 3000 ohms is not there, means we have to go for 3000 ohm resistor. That means we can connect the resistors in two ways so that we can change the resistance value in the circuit. So that's what we are going to see now. So how can we connect the resistors? So two ways we can connect the resistor. One is resistors in series. Another one is resistors in parallel. So this is a symbol for resistor. This is a symbol we often use for denoting a resistor. Suppose if you want to connect a resistor in series, have to connect resistors. You can connect n number of resistors in series. So here I have taken three resistors of resistance R1 and R2 and R3. They are different resistors, and I have connected to a supply. So you can connect like this also. That's what given in your book. So three resistors, they are connected in series. If you take this one, imagine the current I, conventional current I is flowing along this direction. The charge that flows through each resistor remains the same because all the resistors are in series. Charge flowing through each resistor remains the same. So current is same across each resistor. What about the voltage? The voltage is actually divided between these three resistors, like say V1, V2 and V3. And we all know V is the sum of V1, V2 and V3. We know Ohm's law, V is equal to IR. So write here I, R, S. I put suffix X here because the resistors in series. And what is V1? You all know I into R1. And what is V2? I R2. And what is V3? I R3. So since current through each resistor remains the same, so I R1 plus I R2 plus I R3. Now take I outside, R1 plus R2 plus R3. This is IRS. Strike this. So what is the net resistance or equivalent resistance? It is the sum of the individual resistors that are connected in series. Suppose if you take the equivalent resistance RS, this RS is always greater than R1, R2 and R3. Say for example, if you take equivalent resistance, say R1 is equal to 1 ohm, R2 is equal to say 2 ohms, or R3 is equal to 4 ohms, say for example. So what is RS? It is R1 plus R2 plus R3. Simply add 1 ohm, 2 ohm and 4 ohm. So what is the result? 7. See here, RS is 7. This RS is greater than R1, greater than R2 and greater than R3. Suppose if you have connected n resistor in series. Imagine you have connected n resistors of equal resistance in series. So I have connected 3 resistors. If 3 resistors means what do you say? RS equal to what? R1 plus R2 plus R3. So what do you get? 3R. So RS is 3R. Suppose if you connect n resistor, then it becomes NR. So this equation is applicable only if R1 is equal to R2 is equal to R3. Otherwise, you cannot use this equation. This is regarding the resistors that are connected in series. Now let us get into resistors in parallel. So if you connect resistance in parallel, it may be like this. Say R1, R2, R3, or you can draw like this too. So anyway, we can, both the ways we can connect the resistors in parallel to the voltage source. Now the current I is divided between the 3 resistors are I1, I2 and I3. But voltage across each resistor remains the same since the potential is, since all are connected in parallel. So voltage remains the same. So which one is changing? The current through each resistor is changing. So here, since the voltage is changing, we take V is equal to V1 plus V2 plus V3. Now here which one is changing? Current is changing. So I is equal to I1 plus I2 plus I3. Again take Ohm's law. We know V is equal to what? IR. So what is I? V by R. Now substitute in this equation here. V by Rp. Since this is a parallel connection, I put Rp in suffix. Then what is V? I1? I1 is what? V by R1. And I2 is again what? V by R2. And I3 is again V by R3. Now substitute here. V by R1 plus V by R2 plus V by R3. So take V outside, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now strike this V here. So 1 by Rp is the equivalent resistance. It is the sum of the reciprocal of the individual resistor. Now here we saw that R is always greater than R1, R2 and R3. But if you connect the resistors in parallel, this Rp is always less than R1, R2 and R3. Say for example, we can take the same example or different example we can take. So, we can take the same example. Let R1 is 1 ohm, R2 is 2 ohm and R3 is 4 ohm. So, what do you get? 1 by Rp is equal to 1 by 1 plus 1 by 2 plus 1 by 4. So, take LCM, 4 let us take. So, 4 plus 2 plus 1, this is 1 by Rp. So, what do you get here? 7 by 4 or Rp is equal to 4 by 7 ohms. So, this is very less, Rp is very less when compared to R1, R2 and R3. So, depending upon the need, so how much resistance is needed in an electrical circuit, we can choose the resistor value and we can connect it either in series connection or in parallel connection. This is regarding resistors in series and parallel. So, carbon resistors are very small, inexpensive, I said it is very cheap, so we can use in electrical circuits to reduce the current. The output we can use this. So, this carbon resistors have a ceramic core and a carbon crystalline I told you earlier. Now, how this, if you see this carbon very deeply, carbon resistor means it has many different rings like this, say. So, this is the having 3 colors, say orange, orange and orange, and at this end we have gold color. So, depending upon the color it has, we can find the resistance of this particular carbon resistor. So, I will tell you a trick how to find this. So, for this we need a table. Let me draw the table first. So let us get into this, how we could find the resistance value of any carbon resistor. That's what we are going to see now. So first indicates the color. So how we have to remember this? For this we have a mnemonics. Either you also can create some mnemonics. The mnemonics I know that I will tell you now. Say B, Roy, Great Britain, very good wife. Similarly, you can create your own mnemonics, or you see this is actually the rainbow colors. Violet, so indigo is alone missing. Blue, green, yellow, orange and red. Rainbow colors followed by grey and white. So many ways are there to remember this one, and it actually starts with black and then brown and ends with white. That's all. So first G is green, the next one is what? Grey. So next column is denotes the significant numbers. It starts with 0, black starts with 0, then serially 1, 2, 3, 4, 5, 6, 7, 8, 9 you have to put. And then next one is multipliers. Actually in terms of 10 power you have to write this value. So 10 power 0, that is equal to 1. This is 10 power 10 raised to 1, 10 raised to 2, etc. up to 10 raised to 9. The next column is tolerance. Tolerance is, I'll tell you, if it is gold ring, it has 5% tolerance, and silver it is 10%. If there is no ring at all, suppose if you are not having this fourth ring, then the tolerance is around 20%. I'll tell you what is that one. Finally, we have TCR, and what is TCR means? Temperature coefficient of resistance. And this you are not having in your textbook because it comes for some 5 band or 6 band. Only in your textbook they dealt with only 4 band carbon resistor. So I am going to teach only 4 band carbon resistor. So initially we took one example. I said that resistor has 3 colors, orange, 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 and finally it has a gold one. So first 2 you have to take the significant digit for the first 2, and third one you have to take the multipliers. So significant S and multiplier say M. So what is orange? Stands for significant figures, say 3. So color code. So first you have to write the significant figure. The next significant figure is also what? The same color, orange. So again you have to write what? 3. And next you have to write the multiplier. What is the multiplier? Here you have to go here. So how much it is? Into 10 power 3. So what it indicates? 33. 10 power 3 is 1 kilo. So 33 kilo ohms. Now we have gold ring here. I said it is tolerance. So how much it is? Gold has, according to the table, it has plus or minus 5%. What this tolerance indicates. So say for example you take 33 kilo ohm into 5%. What you get? $1.65. So add this what? 33 plus 1.65, so 34.65 kilo ohms you will be getting, and 33 minus 1.65, so what this tolerance indicates means, actually this resistance is not exactly 33 kilo ohms. The resistance value lie between 33.35 kilo ohms and 34.65 kilo ohms, or the resistance value lie from this to this value. So because the manufacturers cannot produce the exact value of the resistance, they are giving this tolerance. So if you want 31 to 35 or 34 you can use this resistor. That is the meaning. We can take some other example, one more resistor. Say for example, this resistor is having, actually while you hold this resistance, for finding the resistor value, you have to hold like this, that is the gold or silver or no ring should come to the right side. The color should start with the left one. That is what I have drawn here. So, the resistor which I am having in my hand has what is it, red and orange, and here it is gold. So, as I told you earlier, the first one indicates what? The significant figure. So, first two indicates the significant figure and the third one indicates the multiplier. So, for red what we get? Significant figure 2. So, 2, again another red 2 into, and multiplier is what? 10 power 3. So, 10 power 3. So, plus or minus, again it is gold, say 5%. So, 23 kilo ohms plus or minus 5% tolerance. In this way, we can identify the resistors and we can use in different circuits.